Hey guys, welcome back to my channel. So in my previous tutorials we have done this fresh air calculation. So next step is do the FAHU design and ducting layout. So we will do the FAHU design now. So you can see this is your next sheet, which is FAHU fresh air calculation design. So this using these sheets we have to design the fresh air. So in our case this is the user input. Okay, so this yellow color is user input. So we have to fill these sheets. Okay, so what you will do, you can see here the flow of air, so flow rate in CFM. So how much fresh air CFM we have calculated here? 1607. So let me, okay, 1607. So here you can first you have to enter the location. So location is Dubai, and the outdoor dry valve, then wet valve, then season. Okay, so to find this weather input, go to this app software, open this app software. Okay, just to save the time, open this one. Okay, and then you can go to this weather property and double click here, and you can select here region, which is Middle East, and location is UAE, and here Dubai. Okay, city is Dubai. So you can found here the summer design dry valve 107 degree Fahrenheit, and summer coincide wet valve is 75 degrees 7 Fahrenheit. So here you can enter the location is Dubai, and outside temperature is 107 degree Fahrenheit, and wet valve is wet valve temperature is 75 degree. Okay, for summer. So here is 75. Similarly, you same value you have to enter here as well. Okay, here is the 107 dry valve on coil temperature, and wet valve is 75. Using these two value we have to calculate these two value. Okay, using the software. And for off coil, you know the dry valve temperature is comfort 76 degree Fahrenheit, which is for human comfort, which is given in the ASHRAE standard ASHRAE handbook. 24 degree for off coil, and humidity is 50%, which is the standard. Okay, so using these two value we have to calculate these two value. Okay, next is the season, which is for the summer, and here is the fresh air CFM. So fresh air CFM we have calculated 1607. So just enter here 1607. Okay, and then this using these two value you have to calculate these two. So open the Psychrometric software. So let me open this, go to this Psychrometric. By using this Psychrometric you can also calculate. Okay, so here let me go to this view and analysis edit. Okay, so here you can see we have to plot the point. You can click here and add the point. So here is the add point, and you can see here the dry valve temperature. Whatever you can select here, you can enter the two value, and remaining value you can got by calculated by this software. Okay, so in our case just minimize this. Okay, in our case here you can see we have two value, which is dry valve temperature and wet valve temperature in degree Fahrenheit for on coil temperature. So enter in this value 107 and 75. So here is the dry valve temperature is 107, wet valve temperature is 75 degree Fahrenheit. So you can see here the RH is 22.4. so you can go to this, and here is 22.4. just update this. Okay, sheet, and here is the W, which is your W. So W is, you can see here 79.5. humidity ratio grain per pounds. Okay, and RH is relative humidity, so we need this W, humidity ratio 79.5. so go to this sheets, just update this 79.5. okay. Now next is your off coil temperature. So for off coil temperature, you know the dry bulb temperature and the relative humidity. So just select these two and you can got these two values. So go to this Psychrometric software, and now here you can select relative humidity, and dry bulb temperature is 76 and RH is 50%. So using these two value you can got humidity ratio and dry bulb temperature. So 76 is the dry bulb, wet bulb temperature. So wet bulb temperature is 63. Wet bulb temperature is 63 and humidity ratio is 67.2. so here is 67.2. okay, there we go. Now next is sensible heat and latent heat and total heat. So sensible heat, there will be one formula here, which is here you can see the sensible heat is 1.08 CFM into delta T. So we have to apply this formula 1.08 CFM into delta T. So here you can see 1.08 and CFM is 1607 and delta T is nothing but the dry bulb temperature difference, which is 107 and 76, 107 minus 76. So here is the already applied formula is set in the Excel program. Formula is has been set. So here you can see once you double click, and this formula will be appeared here 1.08 CFM. B10 is nothing but you can see this is the B row and 10 is the column. 10 is the row and B is the column. So you can see the CFM 1607. And in bracket C10 in minus G10. So C10 is the column C and row 10, which is dry bulb temperature, and G10. So G row and G column and 10 row, which is dry bulb temperature off coil, and this is on coil. So off coil temperature, on coil temperature minus off coil temperature is the delta T. okay. So here we got in BTU per hour and the sensible heat in tonnage. Once you divide by 12,000 you will get in tonnage. Latent heat is as well here, which is applied formula. Here you can see for the latent heat the 0.68 into CFM into delta W. Delta W is nothing but the wet bulb temperature difference. So double click here 0.68 B10. B10 is nothing but the CFM and delta W. okay, so delta W humidity ratio, because this is the latent heat. So F10 minus on coil minus off coil. So latent heat delta W is nothing but the humidity ratio. okay, so here is your latent heat. Total heat, once if you add these two values, sensible plus latent, you will get the total heat, and here is in tonnage. So this is your the total tonnage for the fresh air FAHU. okay, 5 ton required, 5 ton fresh air unit is required to handle this much of airflow. okay, so how much CFM per ton? So let us check. 1607 divided by 5.6, so 286 CFM per ton. So this is how we are designing the fresh air. So for our project we have designed here total tonnage is 5.6 ton. okay, so next step is FAHU design and ducting layout. So FAHU design is over here, and now we have to do in the next video the ducting layout. okay, so please be with me and keep watching my video. So I hope you guys learned something from this video and how to design the fresh air unit. So please be with me and keep watching my video. So thank you for watching my video. Thank you. Bye bye.